Hello and welcome back to Chopstick Maths. In this video, we shall be solving sum number 1 from exercise 4. We'll be solving the given differential equation, which is y raised to 4 plus 2y dx plus xy cube plus 2y raised to 4 minus 4x dy is equal to 0. Now this is the given differential equation. So let us call this as equation 1. Now first of all, let us find out if this given differential equation is an exact differential equation or not. So let us compare this with m dx plus n dy is equal to 0. So we get m is equal to y raised to 4 plus 2y and n is equal to xy cube plus 2y raised to 4 minus 4x. Now let us first differentiate m partially with respect to y, and then let us differentiate n partially with respect to x. And if del m by del y is equal to del n by del x, then we can say that this given differential equation is an exact differential equation. So let us now proceed to differentiate m partially with respect to y. Now m is equal to y raised to 4 plus 2y. So del m by del y is equal to del by del y of y raised to 4 plus 2 del by del y of y. Now del by del y of y raised to 4 equals to 4y cube and del by del y of y is equal to 1. So del m by del y will be equal to 4y cube plus 2 into 1. So del m by del y will be equal to 4y cube plus 2. Now let us differentiate n partially with respect to x. Now n is equal to xy cube plus 2y raised to 4 minus 4x. Therefore del n by del x equals to y cube into del by del x of x. Now whenever we are differentiating partially with respect to x, we will be treating y as a constant. Therefore y cube comes out. So this would be equal to y cube del by del x of x plus 2 del by del x of y raised to 4 minus 4 del by del x of x. Now del by del x of x equals to 1. So this would be y cube into 1 plus del by del x of y raised to 4 is equal to 0. Now since we are treating y as a constant because we are partially differentiating with respect to x, therefore del by del x of y raised to 4 equals to 0. So this would be plus 2 into 0 minus del by del x of x is 1. So this would be minus 4 into 1. So del n by del x will be equal to y cube minus 4. Now you can see that del m by del y is not equal to del n by del x. So the given differential equation is not an exact differential equation. Now we will have to find a suitable integrating factor such that when we multiply this given differential equation with the integrating factor, this given differential equation will reduce to an exact differential equation, and then we will be able to find the solution of this differential equation very easily. Now if del n by del x minus del m by del y upon m is a function of y only, say f of y, then the integrating factor would be e raised to integral f of y dy. Now del m by del y is equal to 4y cube plus 2 and del n by del x is equal to y cube minus 4. Therefore del n by del x minus del m by del y upon m is equal to y cube minus 4 minus into bracket 4y cube plus 2 upon, and here m is equal to y raised to 4 plus 2y. So this would be y cube minus 4. Now there is a negative sign outside the bracket. So when we open this bracket, both these terms inside the bracket would change their signs. So this would be minus 4y cube minus 2 upon y raised to 4 plus 2y. Now y cube minus 4y cube would be equal to minus 3y cube, and minus 4 minus 2 would be equal to minus 6. Now we can pull out the y common outside the bracket. So we can write y raised to 4 plus 2y as y into bracket y cube plus 2. Now again we can pull out the minus 3 common outside the bracket in the numerator. So we can write minus 3y cube minus 6 as minus 3 into bracket y cube plus 2 upon y into bracket y cube plus 2. Now the term y cube plus 2 will cancel out each other in the numerator and the denominator, and we will be left with minus 3 by y. Therefore, del n by del x minus del m by del y upon m is equal to minus 3 by y. Now, del n by del x minus del m by del y upon m is equal to minus 3 by y. That is, it is a function of y only, and we can call it as f of y. Therefore, the integrating factor would be equal to e raised to integral f of y dy. Now let us substitute f of y over here, which is equal to minus 3 by y. So the integrating factor is equal to e raised to integral minus 3 by y dy. Now this minus 3 being a constant, we can pull it outside the integral sign. So the integrating factor will be equal to e raised to minus 3 integral 1 upon y dy. Now, integral of 1 upon y dy is equal to log y to the base e. Therefore, the integrating factor is equal to e raised to minus 3 log y to the base e. Now, we can simplify this integrating factor by using the property of logarithm, which is m log a to the base e is equal to log a raised to m to the base e. So, we can write the integrating factor now as e raised to log y raised to minus 3 to the base e. And we can further simplify this integrating factor by using the second property of logarithm, which is e raised to log f of x to the base e is equal to f of x. Therefore, we can write e raised to log y raised to minus 3 to the base e as y raised to minus 3. Therefore, the integrating factor is equal to y raised to minus 3, which is equal to 1 upon y cube. Now, multiplying equation 1 by the integrating factor 1 upon y cube, we get 1 upon y cube into bracket y raised to 4 plus 2y dx plus 1 upon y cube into bracket xy cube plus 2y raised to 4 minus 4x dy is equal to 0. Now this would be y raised to 4 upon y cube plus 2y upon y cube dx plus xy cube upon y cube plus 2y raised to 4 upon y cube minus 4x upon y cube dy is equal to 0. Now, y cube will cancel out each other in the numerator and the denominator, and only y will be left behind. Plus, here y will cancel out each other in the numerator and the denominator, and what would be left behind is plus 2 by y square dx plus here y cube will cancel out each other in the numerator and the denominator, and only x will be left behind. Now here y cube will cancel out each other in the numerator and the denominator, and what would be left behind is plus 2y, and since there is no common factor which can cancel out each other here in this term, we will be writing this term as it is. So this would be minus 4x upon y cube dy is equal to 0. We can call this as equation number 4. Now equation 4 is obtained by multiplying the given differential equation by the integrating factor. So equation 4 is an exact differential equation, and the solution to this is integral m dx keeping y constant plus integral n dy integrating only those terms in n which are free of x is equal to some constant c. Now m is equal to y plus 2 by y square, and we have to integrate m with respect to x, treating y as a constant. Now the first term over here is y, so we'll have to treat it as a constant. So this would be y integral dx. Now the second term is 2 by y square. Now this y square in the denominator, we'll have to treat it as a constant. And 2 is a constant, therefore 2 by y square will be a constant, and so we'll have to write it outside the integral sign. So this would be plus 2 by y square integral dx plus. Now n is equal to x plus 2y minus 4x upon y cube. We'll have to integrate n with respect to y and integrate only those terms in n which are free of x. Now the first term of n is x. Therefore, we'll have to neglect this term. The second term is 2y, and this term is free of x. Therefore, we can integrate this term. So this would be plus 2 integral y dy. Now the third term is minus 4x upon y cube, and the third term has an x in the numerator. So we'll have to also neglect this third term. So this would be equal to some constant c. Now integral of dx is x, so this would be yx plus integral of dx is x, so this would be plus 2x upon y square. Now integral of y dy, this can be integrated by using the formula integral of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Therefore, integral of y dy is equal to y square by 2. So this would be plus 2 y square by 2 is equal to c. Now we can pull out the x common in the first two terms. So this would be x into bracket y plus 2 by y square plus, now here 2 would cancel out each other in the numerator and the denominator. So this would be plus y square is equal to c. And this is the solution to the given differential equation. Thank you very much for watching the video, and if you have liked the video, please do consider subscribing to the channel. See you in the next video. Bye for now.